there is a 6 microcoulomb charge in the middle here. And what comprises that charge? Well, we say charge is quantized. Why? Because one electron, which is our base charge, is 1.6 times 10 to the minus 19 coulombs. Therefore, everything is a whole number multiple of that. So not every charge is possible. We can calculate the approximate number of electrons that are lost by this positive charge by taking 6 times 10 to the minus 6 coulombs and dividing it by the 1.6 times 10 to the minus 19 coulombs, the charge on the base charge. This equals 3.75 times 10 to the 13th electrons. Now that's how many electrons are lost from this charge. So that's what is meant by a charge is quantized. It's a whole number multiple of our base charge. Okay, now let's look at a certain distance around this charge. Say that this circle here represents a radius around the charge. Then the potential is going to be the same all the way around. So how much work does it take to take a charge and move it around this circle? Well, if our potential is the same everywhere, there's no work done. So let's put a positive test charge located right here on this circle. So there's no net work done if I stay in that circle. Now what if I go into the circle and then come back out and end up still here on the circle? Okay, well, let's say just for calculation that the volts here is, let's say, V sub A. We go here, we would then be located at volts B, right? But when we come back out, we're still at volts A. So regardless of the path that we follow, we still end up at the same potential. So again, no network is done. Likewise, if I start here and move farther away from this charge and then come back, there's still no network done on this. I think of it this way. If I come in here, I go to higher potential. I have to use energy to come closer to the charge. But then I get that energy back as I go away from the charge. Okay, likewise here, I get energy out of the system by letting the positive charge move away, but then I have to put it back in to get back to my same potential. So again, no network's done. So no network is done if your beginning potential is equal to the ending potential. So that's what equi-potential is all about. Work is only done if you're going from lower potential up to a higher potential. Now again, if you go from higher potential to lower potential, then it's negative change in volts. Therefore, you get work out of the system.